Okay, so hope everybody is safe with the rain and what's happening. So be safe at home. Yeah. So today, last week we had learned about more of the current, voltage, then the Ohm's law and all, right? So today, what I'm going to tell you today is regarding you have seen the different equipments in your home. Sometimes it is having, I'll show you, this is your phone charger, okay? If you see your phone charger, if you have your phone charger with you, you can look into it. You can see in the input, there is one value, and in the output, there is another value, okay? If you have, you can go and look into your charger now. If you see in this charger, you see that the voltage, there is a value voltage, right? VV is there. So in the input also voltage is there, output also voltage is there. And in the input, there is ampere is there, right? We learned about ampere. Ampere is there 0.5, and output also ampere is there 1.67 ampere, right? We learned that it is the number of the electrons. It is the coulombs per second, which is running for each electron, each ampere. We learned about that one, right? But if you see, there is one more figure on your charger. That is in the input, you see 50 to 60 hertz, right? But in the output, it is not there. Why it is not there in the output, and what does that mean by this 50 hertz or 60 hertz? Because we learned about voltage, we learned about ampere, and in this particular, for this mobile, it doesn't have this hertz. Okay, so today we are going to look into what is this one, what does it mean by in your phone, in your even your PC also. If you have your charger, you will find that one. Okay, so for example, in the home appliances, you will find it. It will be directly connected to a small plug, right? If you see, there is the 2-pin plug which you will plug into, or maybe 3-pin plug if there is an earth cable. So it will be 3-pin or 2-pin which you'll directly plug into your socket. Okay, but for your computer or for your laptop, I don't know if you can see this one. You will have a small device like this. The plug, you will put it there, and before you plug in into your PC, okay, there is a device like this. Okay, this is called adapter. What does this adapter do? Okay, so that's what we are going to look into that one today. So what does that mean is, okay, this is what we are going to learn about the new concept. One is called direct current and one is called alternating current. Okay, first let us look into what is this alternate current and what is this direct current, and then we will go see why your this one PC and the mobile uses direct current. It uses direct current, and other devices are using alternate current. Okay, so in the direct current, what it means is the voltage is same when even the time passes. The voltage is at the same value. You see on the screen, this is the DC current. The DC, the voltage or the current, it is the same. Right now I'm talking about the voltage, but the current is also this one. Okay, so it is at the same line with the time. When the time increases 1 second, 2 seconds, 3 seconds like that, the voltage is in a straight line. Okay, but in an alternating current, as the name suggests, it is alternating. It is changing with the time. When the time changes, at this time, the voltage is at 0. When it reaches at this time, it is at this point, it is at this value. And when it is at almost when my pointer is, it is at the maximum voltage. So the voltage goes from 0, it varies, and then comes down. It is going like this. It's called alternating voltage. As the name suggests, it is alternating with the time. Now, why this is? Okay, so you remember last time I told you that it is when the scientists in the 18th and 19th century, when they found out about the voltage, at first they found out is the DC current. But with the DC current, what happened, the issue was that one is they were not able to transfer this electricity, that direct current, the DC power, more than a kilometer. Okay, so if it is produced within, they can maximum transport it to only to 1 kilometers. Otherwise, it used to the power used to, it's not economically feasible, or it's not possible for them to do that one. So at that time, Nikola Tesla, you heard about Nikola Tesla, right? That he found out that he is the one who invented the alternating current. So with that invention, they realized that one, we can transfer this the electricity to longer distance. That's what it is happening with us, right? Like the electricity is produced, if it is in Kerala, it might be produced in Idukki, or maybe it is coming from Tamil Nadu, or maybe some other places. Okay, it is coming from there and it is reaching our home. Why it is reaching our home? It was because of the invention of the alternating current, where it is easier to transfer this power. Okay, so that's how the alternating current came into, because DC was not enough for them to transfer to longer distance. So that's the scientist found out alternating current is more, which is varying with time. Now, this is a washing machine, right? Our washing machine. In the washing machine, if you see, there is an, that where if you go and see your washing machine, there is an electronic circuit where you switch on, off, and all those things. Okay, where you said that if it is a woolen cloth type or this, actually that part will normally have a DC current. Okay, because that type of electronic equipments, mostly it is good to work in the DC current. That's why our laptop and computer and all work in the DC current. But in the equipment, the washing machine itself, because it is a rotating machine, okay, it needs more power, and because of that one, AC circuit is used for that one. So if you plug it in that one, there will be a small circuit which will be converting it into DC, which will give to this panel. And it is so like in our what I'm trying to say is, if what we do in our home equipment, we use both DC and AC current, which comes from electricity board to our home. It's an alternating current always. But the batteries, you have the batteries at home, right? The batteries, the 1.5 volt AA battery or AAA battery, actually that is producing a DC current. That is, the current will be always stable like this. It will not vary with time, but which is coming from the electricity board, it will be varying like this. Okay, so this is called varying current is called AC, and the other one is called DC. Now this is what, let's see, watch this video. So in this one, in the direct current, you see, it is like a boat going in a straight line. I'll repeat once more. It is like the boat is traveling, it is going in a straight line. So that's like how you see in the circuit, it is going in a straight line. Okay, but in the alternating current, okay, I'll show you the comparison. This is how we measure this is a multimeter, which we can measure the direct current. Okay, so in the direct current, this will be in the direct, in the DC, in the direct voltage or the direct current, it will be in a straight line. Now let us see what happens in the alternating current. See, alternating, the current is alternating. It is going up and down, up and down. You can, and this one too, and moving boat. Can you see this one? The moving boat going up and down in the waves, and still it is moving ahead. Okay, so this is how the alternating voltage is. It will be traveling, the energy is getting transferred by when it is moving up and down. So that is what alternating current does. And this is what most of our equipments at home, we are using this alternating current. Okay, so now it's the question time. Simple questions. AC stands for? What does AC stands for? We learned two terms, right? AC and DC. What did AC stands for? Yes.
Alternating current.
Alternating current, that's right. Okay, so AC stands for alternating current. Now, what type of current flows from the batteries? The AAA battery, AA battery, I told you, right? What type of current flows? It's an AC, DC, or both AC and DC flows from that. Yes, it is mega. Which one? From the battery, what type of it flow?
DC.
Yes, it is DC, right? Yes, Sriyesh, Avantika, Gilbert, Sriyesh and Sritikesh, everybody has. So from our battery, it is DC current. But when we plug into the socket outlet of this one, it is giving us AC current. Okay. And electricity in our houses. Electricity in our houses. What is the supply, the electricity in our house? It's AC or DC? Yes, Sriyesh, Hrithikesh, Megha. Yes, everybody attempt, then only it will be, yeah, Avantika. It's AC. Yes, okay. So just to get you the concept, AC, DC, at our home, we always get AC, which is an alternating current and a voltage. And DC, it is stable. The voltage and current are in a straight line. Okay. Now, what name is given to the current that flows in one direction only? If the current is flowing in one direction only, what do we call it? Yes, Hrithikesh, Gilbert, we call it as a direct current if it goes in one direction. But if it is alternate, if it is varying, it is called, sometimes it is positive, sometimes it is negative. So then it is called AC current. Okay, now I told you that this is the, now we come to what is this meant by 50 to 60 hertz, what it is written. What do we mean? We talked about that it is varying. How do we mention that? This is this. So, for example, this is one cycle, right? This is one current cycle in alternating current. I said one cycle means it goes from 0, it reaches up to 90, then at 180 it again becomes 0, at 270. This is how the sine wave is. Okay. In the sine wave, when it completes one cycle, one positive cycle and one down cycle, it is called one cycle. Okay. So one cycle is once it goes from 0 to the positive top, then 0, then it comes to the negative. This is called one cycle. Okay. If how many cycles like this per minute, per second? Okay. That is called frequency. Okay. So for example, in this one, in 1 second, you see 2 cycles, right? You see 2 cycles. You see, this is the first cycle, 0 to positive, negative, maximum, and 0. So this is one cycle, and this is the second cycle. And this happens within 1 second. Okay. So when then it's happened in 1 second, it is called two cycles per second. So it is called that cycles per second is called the unit for that one is hertz. Okay, so for that one it is hertz. So for this one it is called 2 hertz because in 1 second it is 2 cycles. So in our home, in your mobile, when it says 50 to 60 hertz means it can vary from it will how many cycles per second? It is 50 cycles per second or 60 cycles per second. So this equipment can work even if it is 50 cycles per second or 60 cycles per second. This model, this Samsung model can work like that. Okay, so the current which is coming to our home, it is varying 50 times. Okay, like it is varying 50 times per second. It is going up and down. Can you imagine how fast it is moving? We cannot imagine, right? It is so fast. 50 times it will move. One cycle of alternating current. I think we should go back to our, in this one, I showed you, right? You see this one, the cycles turning, it will be 50 times, it will be changing this direction in our home. When we have this current in our light bulb or fridge or TV, it is alternating like this 50 times in all your equipments at home right now. Okay. So, and you, I just want to remember that we learned about that North America and all these countries. This one is having 120 volt, and we are having 240 volt, right? Like that, this red countries all are having 60 hertz, and all our countries, the India and all of the blue and the countries in the blue are having 50 hertz. Okay. Now, just for now, I told you that this adapter, what we have, you might have this type of adapter in your home if you see your phone charger or your computer charger, everything will have a adapter, right? Especially the digital equipments will have an adapter. So for example, I told you, this is for my laptop, this is my adapter. So what happens when I plug into my socket outlet, it gets an AC current, but my laptop cannot take a alternating current from that one. So the computer manufacturer or your mobile manufacturer gives an adapter like this. So this adapter, what does it do? It will convert whatever the AC it is getting from your electricity board, and it will convert into a DC, and it will give to your, it will charge your computer or your mobile phone. Okay, so this is, you can see you have your, 1 minute, let me take my adapter. Yeah, this is my phone adapter. Okay, so this is the phone adapter. What does this do? It takes an AC current, okay, and it will convert into DC, and it will provide the charge for my mobile. So my mobile is always charged with a DC current. Okay, so this is an AC current. I told you that this is an half cycle. So in one cycle, it is how many cycles per second? It is called hertz, which is called the frequency of an electrical circuit. Now, for example, if this is a motor of direct current, this is how the current and the voltage will flow. In the alternating current, it will be alternating 50 times in hour, this one. Okay. So this is the transmission line, which I told you in the previous class. Previously, it is produced by any, maybe this is a windmill or maybe any other source. It is getting increased. This voltage is increased by this transformer, and it goes into the transmission line all the way kilometers, and so many kilometers it travels, and it reaches our home. It reaches our home. For this one, alternating current is used because this reduces the losses. Okay, the DC current, it's not easy to transfer that one. So when it reaches to our home, again, there is a transformer which will reduce the voltage, which we can use it at home, and it reaches our home. Okay, so that's what alternating current is used for this purpose too. Okay, small question time. The frequency of AC current in India is? What is the frequency of AC current in India? Yes, Sritikesh has answered. Chakki, yes, A. So India, it is Gilbert 50, yes. Okay, so India, it is 50, and North America and that type of countries, and I think in Saudi, it is there. It is, and somewhere in Japan side, there are some countries which is having 60 hertz. Otherwise, most of them are having 50 hertz. Okay. Now frequency, how it is measured? Frequency, how it is measured? It's measured in cycles per second, time required to complete one cycle, expressed in hertz, or all of the above. Is all of the above correct in that one? It's measured in cycles per second, time required to complete one cycle, it's expressed in hertz, or all of the above. Yes, Vinayak, yes, Ritikesh, Gilbert, Megha, Haripriya, Sriyesh. Yes, the frequency, we saw that one, right? It is measured. Frequency means how many cycles per second. Okay, so the first one is correct. And is it the time required to the frequency? It's time required to complete one cycle. Also, it is expressed in the unit is hertz. So all of them is correct about the frequency. Okay, so this is, which I told you, that alternating current equipments, the oven, the major equipments in our home work on the alternating current. If you see the plug of that one, it's very small plug, right? The 3-pin plug or this one, there is no adapter or anything on that one which converts AC to DC. It is direct current. So what happens if you connect any equipment which is having direct current to the alternating current, it will not function. Okay, it will spoil the equipment. So don't do that one. We have to always plug into with the right plug for the equipment. Okay, so this is the adapter which changes the direct current, the alternating current which is received from the power supply, and when it reaches the computer, it is a DC current. Same thing with this one. This is the adapter for the phone, and when it reaches the phone, it gets a DC current. From here, it is getting AC current, which is from the electricity. Now, we go to the next concept of this one. Like, for example, in our home, okay, we need the electricity power requirement is small because our washing machine is small, or fridge is small, or laptop is small. But when it comes to the industrial applications, okay, like for example, you see a chiller, if it is like the Lulu, this one is having air condition. It cannot have small the window ACs or the split ACs like in your home, right? It needs big equipment. So what happens in that one is the 240 volt supply which we get at home, which we use for at our home, will not be sufficient for that equipment because it's not economical, and it will not be economically viable, and it's not good to this one. So that's why you might have heard about the single phase current, single phase, and the 3-phase supply. Okay, this you might have this is the term, the single phase supply or 3-phase supply. For the single phase supply, like in our home, we might get 3-phase supply, but our equipments are normally, if you have some major like if you have like the farming, if it is big motors are there, maybe you will have 3-phase motors. But in a normal home, we will have only the equipments which is single phase type. Okay, it is well explained what is the single phase and the 3-phase here. Now, what happens in single phase? There is only one sine wave, okay, which is changing, which is getting to our equipment. Okay, so it's only single phase means there is only one phase of current and voltage which is coming to which is going through that wire. Now in a 3-phase, what happens in a 3-phase? If you see in the single phase, there is only 2 wires coming here, right? 2 wires coming, 2 wires going out to our equipments, and for each one it is only 2 wires. But in 3-phase, you see this is red, yellow, blue wire. Okay, so if you look into your home, most probably it will be 3-phase. With your parents, go and see if it is which supply is coming to your home. Okay, if it is 3-phase supply or single phase supply. Some houses will have single phase, some houses will have 3-phase. Go and check. Okay, so 3-phase will have red, white, blue, and this black, that is neutral, which will go in details later on when you become big. So in this one, this is a 3-phase supply might be coming. But after that, when it is coming 3-phase supply, the sum of this one is going to, that this is the one phase is feeding this circuit, second phase is feeding the circuit, and third phase is it. What does it mean is, you see, there is a multiple, the first wave is like that. Second wave, you see the red wave, it is like this. You see the blue wave, so it is 3 separate waves is passing through these circuits. Okay, so it is 3 times than the single phase. Okay, that's how it is here, but it's not actually this one. So now this is what a single phase motor, it is, there is only one cycle of it which is going through it. Okay, so and it is measured the single phase, it is one cycle of current is going through it. Now what happens in 3-phase? Okay, it is 3 times. It is, you see the single phase, it was only one, this one was there, right? But if in 3-phase, you see 3 different circuits will be produced, and it will be going like this. Okay, so this is what it is called 3-phase. So what happens? Big motors and all, it will be better that if we give a three-phase supply so that it will work in the full efficiency, or it's more efficient, okay, than the single phase. So this is the single phase, and the three-phase single phase, it's only one cycle. Three phases, it will be three different waves will be passing through it. Okay. And our electricity, which mostly reaches it generated, is in three phase. It is generated. It is more economical to produce in three phase also. That is the reason. But in our the bulb in our batteries and all, it is just single phase direct current. Okay, it's now the single phase find their application at. Where does the single phase voltage find their application? Where does the single phase find their application? Yes, it is for the small homes, the homes and small shops. And three phase, it is mostly in the large commercial industries, right? Everybody's getting the answer. Okay, now three phase power is simple, efficient and cost effective than single phase power. Is that right? Is that statement right? The three phase power is simple, efficient and cost effective than single phase power. What do you think? I think it's not simple, but it is efficient and cost effective, right? It's not simple, but it is efficient and cost effective than single phase power. Okay. Now voltage produced by three phase system. Okay, if I don't know if I mentioned that one, single phase in the, I told you that at home we will have 240 volt, that is the single phase. When it is three phase, the voltage is 415. I think I didn't mention that, so I'll explain here. So it is the voltage produced by three phase system is 415. Just go and see the distribution board at your home. Okay, with the help of the parents only, go and see that what is the voltage on that one. It is 240 volt or it is written 415 by 240 volt. So if it is 415, it says the three phase is also coming to your home. Okay, now this is an example. If you see in this one, I just wanted to say that how the wiring is. Okay, so now this I told you that R, Y, B. If you see in this motor, it is coming, three wires is coming there, right? And here only red and black, here only yellow and black. So can you tell me the motor, is it a three phase or single phase? You can chat or say if it is three phase or single phase motor. Motor is a single phase or a three phase? Yes, it's a three phase, right? Mega said three phase, Ritikesh, Haripriya. Yeah, right. So you can see that one, right? Because R, Y, B wire is coming to this motor. So it is a three phase. And what about the power socket? Power socket, is it single phase or three phase? Is it single phase or three phase? Yeah, I know that you know that one. It is single phase, right? It is single phase. And also for this bulb, it is single phase, right? Because it's only one wire and neutral which is coming. So it is only that one wave of this one is passing through this, but in this one it is three waves is passing. Okay. So that is what electrical. Now, so we learned about the single phase, three phase, and also what is alternating current and DC current. Now, when we plug the electric plug, okay, electric plug, when oven is plugged, it becomes hot, right? It becomes hot, the electricity is converted into heat energy. Now in motor, when you're washing machine, what happens? It gets rotating. In an iron box also, it gets, this one gets heated and we can use that heat to iron our clothes. In the light, it gets converted into, when electricity passes through it, the 240 volt electricity passes through it, it gets converted into light energy. In the fridge, it becomes cold, right? So now here is the question. When you plug it, when an oven is kept, this one, what is the electrical energy conversion happening here? You can chat, tell them there is no options. So what is the, let me put the chats. Yes. What it is, electrical energy is converted into what here? I know everybody knows. Yes, it is converted into heat, right? Now here, the electrical energy is converted into electrical energy is converted into yeah. Yes, Megha, it is light, right? When we plug it, it is produces, it's a table lamp, it produces light. Now what happens here? This is a mixie, then electric current is this one. What happens here? What happens in a mixie or in a grinder? What happens? Electric energy is converted into a rotating energy. There is a motor which rotates. When it rotates, the blades move. Because of that one, the things get grinded or crushed in a mixie, right? Now here, in a gold plating, what energy is this one? How the electrical energy is converted into what? You know that gold plating, you know that this one, this is the gold bar. It will be kind of, you know that this is an coin. It will be when in this process, this will be kind of coated with the gold molecule, the gold atoms of this one, then this will become gold. What it is getting converting? The electrical energy is converting into what? Can you imagine what is electrical energy getting converted to? Okay, let me tell you. It is because it is wireless. Yeah, no, it is basically, you know, the chemical energy, because from the battery, the current, when it reaches to this one, the ions, the electrical, from the gold ions are released and it get deposited. So it is a form of chemical energy which is getting transferred. So here in the gold plating, the property, the electrical energy, electrical energy is converted into chemical energy to have this process. Okay. Now in the motor, as you know that it is again, it is rotating, and the motor can be used for a lot of different purposes, right? It can be for water. What about your fan? Okay, fan, it is a rotating machine, right? It is a motor, small motor is there, which is getting rotating, and the fan leaves rotate, which will produce the heat. Sorry, which will produce the moving air, and which will make us feel cold. Okay, so this is what the motor does. It's a same motor. It can be used for pumping water, or it can be used to rotate a fan, or it can be used to rotate the mixie, or anything, any rotating machines. Even the car, you know, the car or anything. This is rotating machines. Okay, it can be used, the electric cars. Okay, it is the used to for the electricity is used. The motor is used to rotating that. Now, do you have inverters in your home? Do you have inverters in your home? Like yes. When the,
yes.
Yes. Okay. You know what is an inverter? What does the inverter function as? What does the inverter do? So who said yes? What does an inverter do in your home? What do you think? What happens when, what does it do? If inverter is not, or what does the inverter do? If inverter is not there at home, what will happen? Anyone? You can unmute and say. Yes, Ritikesh says stores current. Okay. What does it do? I just want the function. What does an inverter do? Means when what happens? What have you observed about an inverter in your home? You can unmute and say. Stores current and uses, Ritikesh is saying, and uses it when electricity is gone. Yes, stores current and then uses when the power cut is there. Power cut goes. Yes, right. That's what it happens, right? That in case of in the normal condition, we get the power from the electricity board. But if the power is not there, we get this one from the inverter. Let us see how this one happens. So inverter has two parts. Okay, one, there is a box which is with all the electronic circuits and electronic device in that one, and there is a battery. Okay, the huge battery which is there, where sometimes you used to pour water into that one and all, right? That is the battery. So let us see how it happens normally. So this is one of your home connection. What happens in the home connection? The electricity is coming from the electricity board. It comes to an energy meter. Then it goes to a fuse. It goes to a distribution box that is already, it's called DB normally, or MCB distribution box. From there, it goes into your light, into your fan, into your TV, or wherever it is going. Okay, it can feed all this. So what happens when the current goes off? Okay, there is no supply from this side, right? There is no supply, this is dead. So there is no energy flowing through this one, and none of the circuits work. So what happens with the inverter is, what we do is, we give an inverter here, okay? We connect it when when your parents and the electricians, they worked on that one. What they did is they put an equipment and they put a battery. So what happens in the normal condition is, like when the current is there, when the supply is there in your home, the supply comes to this one. It is connected to a plug and it is feeding this inverter. So what does the inverter do? Inverter does, it will convert this whatever the energy it is getting, and it will store in a battery here. Okay, so and then when the battery and it is getting stored, when it is filled, and it stops charging. And when the electricity goes, okay, and when the electricity goes, what happens? Since there is no supply from this battery will give supply to this inverter, and it will feed all our devices here. It will feed the current to this, so that our lights and this one switch or this one, whatever the circuit it is getting connected, it will get the supply to that one. That is what happening in the inverter. Now let us see what happens inside an inverter. Okay, so inside an inverter, this is the supply which is coming. Okay, this is the supply which I told it is coming. So this is the supply which coming. So what does it do is, the battery, we told that it is having only DC, right? It can store it only in a DC form. DC, it is a DC current, direct current. But all our devices uses AC current. So what does an inverter does is, it gets an AC supply. There is a rectifier device called rectifier. It converts AC into DC. Okay, this converts AC into DC, and it will be getting stored has a DC in the battery. Right? It gets stored in the battery. After that, when this supply goes, okay, it has a sensory circuit in this one. When this supply goes, what happens? This battery will feed the DC supply to this inverter device. Okay, that in the total our inverter, this one is a rectifier and an inverter, but it is the device is totally we call it as an inverter. So the DC, in the DC, it will be converted, a battery will give supply to DC, it will convert into AC, and we will give the supply for our lights or TV or whatever it is. Now, what is the limitation in that one? It is what is the energy stored in this battery, right? That how much battery, how big is your battery at home, or how much is the capacity of that one. So we can use it only because now it is limited. Okay, that whatever it is stored in the battery, only you can use. Now, if it is going for 1 hour, maybe it is fine. Okay, you can switch on your TV, you can switch on your lights everywhere, and you can switch on your the fans. But what happens if it goes for 3 hours or 4 hours like that? This battery will not have the stored energy, might have been already used by all your lights and TV and all. So that's why your parents say when the inverter, when the supply goes, when it is on the inverter, switch on, switch off the unnecessary things. Use only the thing. Why? Because the battery has only very limited storage capacity, right? So if you want to use it for longer time, it has to be used for very carefully, because in the battery it is limited. So that's why your parents say don't you switch on the TV, because I always used to say my son, don't switch on the TV when the current is, when the supply is not there, because TV, you remember the TV, we said that when the power required for the TV is around 200 watts. But for the bulb, it's maybe 20 or 10, 18 or 15, like that only a bulb needs. And a fan needs maybe 40 watts or 60 watts. So that is, that it will get, the battery can make them function for longer time. But if it is TV, it is 200, it goes off immediately, right? It means immediately 200 watts is taken every moment. So this is what happens. This is just in the other supply, sorry. Other supply goes and inverter supply will feed this one from this battery. Okay, so that's why your parents say don't use it when the supply is not there. Don't use the unnecessary things and unnecessary switches, this one and all. Switch it off when it is from the inverter supply, because battery has limited this one. So what is an inverter now? What did we learn about an inverter is? It changes AC electricity into DC, or changes DC electricity into. Vinayak, what was your question? I thought MCV was first. Vinayak, you want to unmute and say, what did you mean by MCV was first? Vinayak, you're talking about this one? You thought this MCV will be first? No, first will be the energy meter, because first it comes to the energy meter and then it comes to a fuse. Then only it will come to the distribution box. Is that what your question, Vinayak? Okay, Vinayak, when you're ready, you can ask, no problem. Okay, so what will be an inverter is? Inverter. So in inverter, the inverter not as an equipment. In that one, we saw that one, there is a rectifier and an inverter, right? I'm talking about that inverter. What does it do? It changes from AC to DC or from DC to AC. What does it do? Do you remember? What was this? In the inverter, what it is converted? Inverter will convert from inverter
DC to AC.
Yes, it will convert from the battery, which are the DC supply, it's coming, it reaches this inverter component, and DC, it is converted into AC. Okay, so then inverter is changes DC electricity into AC. This is the inverter, it will convert DC into AC, right? Now, the rectifier. What does the rectifier do? It changes from AC electricity to DC or DC electricity to AC. Remember the picture? What does the rectifier do? It is A, right? Chakki, Tikesh, yes. All are understanding that it is A. It converts AC electricity into DC, right? The rectifier will convert AC into, that is from the mains, which is coming from our electricity socket. It is AC, it will be converted into DC and it will be stored in the battery as a DC current. Okay, now what does the dash stores electrical energy in an inverter? What is the device which stores electrical energy in an inverter? Ritikesh, yes. Rectifier, battery, inverter, or all the above. What does dash stores electrical energy in an inverter? What stores? I got only one answer. Ritikesh only? Mega battery. Chakki B, yes. Okay, so that's what it is, battery pre also, yes. So you get it, right? So the in the battery is the one which stores the electrical energy in this. Okay, this is just wanted to show you a home connection, how it goes. It comes from the, all these equipments will be connected. I think it's fine, yeah. So this is what the home connection is, Vinayak. Yes, this was your question, right? That energy meter. Definitely, first it is coming to the energy meter. You can look into your home connection. Okay, it is energy meter, then it comes to a fuse, and then it comes to an MCB box. Okay, and then it is from their MCB box, it is given to different devices. Now, let's look into, I think we have few more minutes, 10 more minutes. Let me see if I can finish it off. The electrical power. You know the mechanical power, we pull with the force, we have this one, right? That is mechanical. The rate of doing work is called mechanical power, right? So like that, electrical power is rate of doing work. That with the electrical energy, that how much work can be done. That is called electrical power. Remember that in the power and the electrical power, we remember that in the first, this one and all, we learned about watts, that that iron box is 1200 watts. That is the electrical power. The watt in the light bulb was 23 watts. That is the electrical power of that. Now, what is called electrical energy? Okay, what is called electrical energy? The electrical energy means it is the power, that how much time we are using. For example, if you are using that power, that iron box for 1 hour or maybe 2 hours, okay, so that is the electrical energy consumed by that. The power is 1200 watts all the time. That is the power. But the electrical energy, when we say, is that how much time we have used that one, or maybe the light bulb. Light bulb maybe will be 23 watts, we might be using for 8 hours. The fridge, 24 hours, right? If it is fridge is 140, 200 watts, we are using it for all the time. We are using it for 24 hours, right? So maybe it will not be all the time, it will not take 200 because the cooling, it will be very limited, that when you open the fridge only, the cooling goes. So only little power, the power is required to that one. Now for AC, if you are putting the AC for whole night, okay, if it is very hot during the summer and if you put AC, it will be that much, how much, maybe the 2 kilowatt of power, it might be taking for 8 hours of time. Okay, so that is called, but the rating on that one, it is called the electrical energy. So you got the electrical energy. I'll come to that. I'll explain with more values on this one. Now, just wanted to show you this this one. You know that I told you that electrical power is voltage multiplied by current. Okay, this is a small demonstration of the, you know, that small fan is rotating. If you see in this one, this is ampere. Okay, see 1.8 ampere, and at 1 volt, this fan is rotating at a particular speed. Okay, so the electric power of this one is this one. So power is, it is measured in 1 watt. And another value of that one is joules per second. That is work done. That's what we said. And it is measured in watts. Okay, so electrical power is in what we say in watts. What it is at which electrical energy is transferred by an electrical circuit. So what you say that wattage, that is called electrical power. Now electrical energy is multiplied, the time multiplied by the electrical power. I'll explain you more. So we talked about electrical power and electrical energy. So electrical power, we said that one. We learned earlier that it is the multiplication of voltage and current, and electrical energy is power multiplied by the time, right? So tell me, what quantities do you need to calculate the electrical energy? What quantities are required for you to calculate an electrical energy? Current and voltage, power and time, resistance and current, power and voltage. Yes, power and time, right? Time in minutes or hours. Now, time is always in seconds. Sorry, in the kilowatt hour, we will say in hour. I'll come to you that one, Hitesh. Okay, check it is B, right? Power and time is what you want to need to the energy. Now, for what do you need to calculate for the power, electrical power, what you need? That we learned in the beginning itself, right? We need current and voltage. Current and voltage is required to calculate the power. Now, if you ask your parents, okay, ask them to give you your electricity bill. Okay, let us see in the electricity bill what will be the how much consumption, how much power your home is consuming. Let's learn about how to read this one. If you see this highlighted ones, you see the power, it is written in kilowatt, and here the initial reading is this much and the final reading is this much. So difference of this one. So it is for this home. This is my home in India, Kerala. So in this one, they're saying that one I have used 863 kilowatt hour. I have used it. Okay. So let us see what does it mean. 863 kilowatt unit. You remember that we learned about the iron box. It was 1440. I think that's what we take. And the time. So what is the electrical energy of this one? We know it is power into time, right? What is the electrical energy of this one? Quick maths. Can you do? What is the electrical energy for this iron box? What is the electrical energy for this iron box? The power is, electrical power is 1440 watts and time is 2 hours. So giving multiplied by hours only. Okay, because we can say watt hour. So Hrithikesh is writing 2880, that is 1440 multiplied by 2. That's right, Hrithikesh. It is energy is equal to 440 multiplied by 2H, that is called watt hour. Okay, 2880 watt hour. Okay, make also, yes, got it. So, and that one, I wanted, it is better that we write it very big figure when it comes. We write it, we divided it by 1000 and make it into kilowatt hour, kWh. Just it is just a multiplier, divided this one by 1000 and put 2.88 kilowatt hour. Now let us see for the TV. If I'm using a 240 watt TV for 4 hours, how much is the energy for that one? Quick one, quick maths. 960, Hrithikesh, yes. Haripriya, yes. Everyone, quick one, quick one. Avantika, yes, yes. Hrithikesh, yes. 0.96 kilowatt hour, that's right. Okay, so it is 0.96. If I use the TV for 4 hours, it's 0.92, 0.96 kilowatt. But if you see if I use iron box for 2 hours, it's almost 2.8. That's so higher than this TV. Now, if I use my microwave, it is a power of 1000 watts. And if I use for 30 minutes, how much will be that one? I want it watt hour. Okay. So be careful how much will be for this one. I want in watt hour. So what will be the power for this microwave? Okay. First, we have to convert this 30 minutes into hour. That is how many hours? 30 minutes is how many hours? Because we want it in kilowatt hour, right? Always energy, electrical energy. We are looking into our electricity bill, right? It is in kilowatt hour. So it is Diljit. It will not be, you have to convert this 30 minutes into hours. That is 0.5 hours. Okay. So it is 1000 multiplied by 0.5 hour, which is 500 watt hour. That is equal to 0.5 kilowatt hour. So the microwave, if I'm using it for 30 minutes a day, I will use 0.5 kilowatt hour. Okay. So let us go to this one now. What does this mean now? Okay. So I'm using 863 kilowatt hour. Okay, if I add all these things, 2.8, 0.96, 0.5, this is maybe I'm using it per day. The equipments I might be using it, right? So this is the total I'm using it per day, and there will be lights and fans in my home. Okay, along with that one. So when I do it for monthly, maybe this is for 2 months, I think. Okay, this is for 2 months. Or maybe 1 month, I'm not sure. Okay, so this one, it is saying that one I'm using 863 units. What does each unit means? Each unit is in kilowatt. That means I'm using 8,63,000 watt hour. According to this, my electricity bill, I'm using 8,63,000 watt hour, or maybe 863 kilowatt. Okay, so if I multiply, that is why every equipment you use, okay, that's why parents say don't switch on the light all the time, unnecessary when you're not there. Don't keep the TV on, because this energy is getting consumed, and it is a wastage of so much of energy, national wastage, right? We should not do that one. So we should do it. We should, because this is getting consumed somewhere, that energy is getting used. So once you are not using, switch off the things. Otherwise, your bill will go on increasing. And it is not only the money related, it is also a national wastage. We are not supposed to waste energy by any means. Okay, so this is now in your next meeting, next in the assignment, I'll put it in our session. Your electricity bill, find out how many units you use per month. Okay, and then do it maybe one in June and one in December. June or maybe April, take it April, that is hot time when you have too much of fan or maybe AC. Take electricity bill of April of any year and maybe December of that year. Okay, and see what is the unit difference you use. Okay, that is your next assignment. Figure it out and come back. Okay, then so that you will know that how much power is used in your home. So this is just a common electrical issues. I just wanted to tell you that the fuse blown, the lights not working, the plug not working. Sometimes, it might be you see your plug like this, it might be burnt, or maybe your switch is like this, it is burnt. It will not be working. What happens is, okay, the fuse is, you see, this is the fuse. Okay, the electricity board. This is the library. Yeah, this is the fuse. It is coming. Okay, the fuse. The good fuse is that it is continuous. In the electricity, there is one thing. It is always the circuit has to be continuous. So if this one is blown out, current will not come into your home. Sometimes when there is no power supply is there in other homes and it's not in this one, your parents might be heard is the fuse gone. Okay, that is because this is the fuse, which is, or maybe in the movies you might have seen, right? They go and replace the fuse and do it. Okay, and then so that's what the fuse is. Then this is the simple electrical circuit I told you, right? It should be continuous. In the normal house, we will have this as a socket, the plug we will have it. So it has to be continuous. What happens by any chance, if any of the circuit is blown out, what happens? The current will not flow to that one. It has to be continuous always. Okay, so what happens in this circuit is, because this one is broken, whatever you plug it into that one, it will not make a continuous circuit. That is the reason sometimes when the plug is this one like this, you will see that when you plug it in, it will not be working because this is blown out. This one is not, the connection is not getting proper and it will not be full circuit. Same thing with this switch. The switch is blown out. There is no way that, that the circuit can be complete. That switch is not getting closed because it is blown out like this. Okay, so sometimes that is the reason. So you have to switch off this one. And sometimes, the serial bulbs you put it during the time of the Perinal and all those festivals, right? In that one, what happens if one of the bulb is gone? You see that it is completely gone. You know why? Because the circuit is not complete. That is the reason why that full circuit is not working. Okay, so this is what we have in the module 3 that we learned about AC and DC current. We learned about frequency, right? Number of cycles. Then we learned what is 3-phase and single phase. The 3 different waves are there and which is good for large industries. 3-phase is used. And we learned about inverters. What does inverter do? It stores energy in the battery and it is used when the supply is gone. The electrical circuit, then we learned an energy and power, right? And how to read your electricity bill, right? So this is what today's class is. Any questions or anything you have it? If you want to have it, let me know. Or you can put it in the session box, this one. I'll put this assignment now for the, that look into your electricity, this one, and come and we will figure it out.